Good morning, good afternoon, everyone. Welcome to Fundamentals for Startups, a CoMotion Labs production. My name is Soraya Bailey, and I'm the Innovation Training Director here at CoMotion, and I am your host today. So if you've joined us before, you know that at CoMotion Labs is a multi-industry incubator hosting early-stage startups from both inside and outside the UW community. We are committed to nurturing and enabling the success of our startups, contributing critical infrastructure and opportunities for learning, mentoring, and networking. And we do this without taking equity or IP. We have 3 incubators in 2 locations on campus, life sciences and hardware over in Fluke Hall, and tech here in our startup hall. If you are a founder looking for a community to help your startup grow and flourish, we would love to talk to you. Fundamentals for Startups is a regular lecture series open to anyone interested in learning about entrepreneurship or building a startup. Every week, we bring in experts and with diverse perspectives and experiences to share insights, inspire action, and offer space for questions. So a few announcements before we get started. All of the Fundamentals for Startups presentations are archived on our YouTube channel and the CoMotion website, where you can filter the topics by topic. You can also learn about and register for future Fundamentals events by visiting our CoMotion Labs website or subscribing to our YouTube channel. All right, well, let's get to the fun part. Today, I'm really excited to introduce my colleague, Dean Pettit, a former life sciences product developer and a UW PhD alum, who mentors and lectures bioengineering students on how to work with the latest industry-specific tools that they will need to navigate their careers and their career pathways. Today, Dean will talk about a startup case study and strategies that can empower CoMotion Labs members working at the intersection of global health and product development. Also, as you may have noticed, there is a mic in the middle of the room. Dean welcomes questions at any point during his presentation. So, welcome, Dean. Thank you so much for joining us today.
Great, thank you, Soraya. Yeah, okay, I should be in the camera's zone here. I was able to meet a couple of you, and I understand primarily this is a startup venture building and a startup venture class, and these are your interests. And I'm going to talk about a startup that I was involved with called Just Biotherapeutics. And some of you may have heard of that, I'm not sure. And it's a bit of a unicorn story, I have to say. And so some of these things are not typical. And we had a lot of momentum behind us before this thing ever even hit the ground. So it's a bit unique, but I hope that some of the ideas will be relevant to all of you. And first, just a little bit about me. I got my undergraduate degree at UC San Diego, which is one of the most beautiful campuses in the world. It's spectacular, if you've ever seen that. On the bluff up there above La Jolla, and I was drawn there a lot just because of the beach. It was so fantastic and beautiful. I worked for an eye care company called Allergan, and we made devices at the time for corneal refractive surgeons. So they could change the curvature of the eye, and this predated what we do now with LASIK. And these were lens products. They're human tissue that we processed into the shape of a lens and freeze dry it and sew it onto somebody's eye. And this was in the early 80s. And we were starting to watch the news, and somebody walked in and said, there's this thing called HIV. We have no idea what this human tissue, how it's been tested, what's happening. And it put the whole thing out of business as a business arm of what we were doing at Allergan. And we got the idea to do this out of polymers, synthetically. And my boss said, can you find a place that we can collaborate with to do this? And I thought, why not me? I'm ready to go back to grad school. I can do that work. And I found a university that's got quite a reputation in biomaterials science, and that's how I ended up here, working on this with my company, Allergan, funding that behind me. So that was a great experience. And I worked in protein engineering eventually, because biomaterials eventually is all about proteins, protein adsorption, protein conformation, this type of thing. I went on after my postdoc to work at Immunex. Some of you may have heard of Immunex, and it's the story of most life science companies in Seattle that are successful. Even the ones that make it, they get bought. Things happen. People buy their products. Consolidation of companies occurs. Efficiencies occur, and unfortunately people get moved off, but it was interesting. And we got bought by Amgen, and Amgen I worked at Immunex for maybe 10 years. I worked at Amgen for 12 years, and then Amgen pulled out of Seattle, left, and a small group of us started this company called Just Biotherapeutics. And I worked there. I started 10 years ago. We started the company. And just recently, I've started working again at the university as a lecturer. So I've come full circle, and I'm teaching a course this quarter called Technology Commercialization. And next quarter, I'm teaching a course called AI Applications for Bioengineers. And these, I think, are really current, interesting. I'm really excited about these topics, and that's been a lot of fun for me getting back to the university and doing these things. So I'm going to say a little bit about Just, and I'm going to start off with the mission. And in my course, I pounded this into my students about how important the mission is. A lot of times you just use some words, it's pithy, easy to say, but I think the mission is so critical. And our mission is still there. Design and apply innovative technologies to dramatically expand global access to biotherapeutics. So what we were trying to do was apply the technologies we had learned while working in these biotech companies in ways that could drive down the costs and help people access these kind of therapeutics that are really inaccessible to most of the world. They're only accessible to people that can afford to pay tens of thousands, hundreds of thousands, millions of dollars. And it's kind of crazy that you're born on one side of an arbitrary line, and you have access or you do not. So that's what the company was all about. The mission, I can't tell you how important it was when we started the company, and I would have people come for interviews, and the first question I wanted to answer always was, why are you here today? What's the reason you're here in my office for this job interview? And I can't tell you how many times people said something to the effect of, have you seen your own website? Do you know what you're doing? I want to be part of that. This is why I'm a scientist, because I want to put my finger on something that helps patients, and this is the place that I can do just that. Look at that mission. And I always had to say, we can't pay you as much. We're not making a lot of money. It's kind of gritty, bootstrap kind of activity we have going on here. And it was okay. And if I chased some people away by saying that, they weren't right for us at that time. We needed those people that had so much passion about what we were doing that they just wanted to be part of changing the world. And that's what we did, I think. Let me talk a little bit about the technology. And in a nutshell, let me explain how this works with typical pharma companies on the left. And they tend to do work in ways that is what we could call siloed. They're in different silos. So a group of people does work in discovery, and they're looking for a certain mechanism of action of a molecule, perhaps. And they work with animals, and it's very important. And maybe it's the lifeblood of the company in a way. But once they've done that work, then you think about a molecule. Like once they've identified a mechanism for some disease, maybe rheumatoid arthritis is blocked by tumor necrosis factor. So if we had a drug, and what would that drug be that would block the action of tumor necrosis factor. And then another group would design that molecule. It might be a small molecule, it might be a protein therapeutic, whatever that was. But it was a different group from discovery. And then once we had that molecule in place, we would throw it to another group, and they would develop a process for manufacturing that molecule. And I was in that group. And I was like everybody else. I thought what I was doing was the critical piece of all of this. And I would tell everybody, okay, I got my molecule. Everybody stand back because I'm going to do process development. This is a big deal. And we invested a lot of money in developing cell lines, scaling this into bioreactors, purifying the protein and putting it into some kind of a formulation, a liquid or what have you. And it was a big deal. And then we would send it over another fence to a group in manufacturing who would say, everybody stand back because we're doing manufacturing. This is the most important part of all this. And really, especially in a larger company, we had no connection between the plant and molecule design. They were disconnected. It's too big. The backgrounds of these people is too diverse. They were disconnected. And we didn't like that, myself and my co-founders. There's too much that we could learn in manufacturing from the molecule, or vice versa. When we're manufacturing a molecule, we could tell the discovery people, hey, all things being equal, can you pick a molecule that's easier to manufacture? And we'll give you that information. And the more data that we started to collect about these molecules, the more information we could feed back to the people who were doing the molecule work and the discovery work. And so we saw this more like a circle where we would do discovery, optimization, a process, a manufacturing process, and then that would inform the discovery of the next molecule, the type of molecule we would have. I'll try to give you one example. I'll give you one example of this, so this will come to life a little bit. Molecules have different viscosities. Antibodies have very different viscosities. So how much you can inject in a single syringe with 1 ml depends on the viscosity of that solution, especially if you've got patients with something like rheumatoid arthritis and they can't get their hand around it and press it with high viscosity. Well, we start to learn things about viscosity later in the process than discovery. Discovery, you can find a molecule, put it in a mouse, it works great, you throw it over a fence, people process it, and then you start to formulate it and you say, this stuff is hard to inject. We're going to have to sell it as a product in 4 separate injections. It's really untenable. It's just, it doesn't make any sense. So what we need to do is learn from the processing and the manufacturing and understand how sequence affects viscosity and feed that information back to discovery. And for me, in my later years, we'll talk about this a little bit, but AI is going to be the driver for us in the future to be able to do this and learn from a lot of data and make predictions about what kind of properties are most useful to us. And after all, if you think about an antibody and a B cell could care less that you're going to make this molecule in a host cell. Who cares how much can get expressed? Who cares if it's viscous? Who cares if you can store it in a vial and ship it around the world and have somebody use it? B cells, there's no selective pressure on a B cell to make an antibody that has properties that are desirable for a pharmaceutical. So we need to engineer it and think about this. Okay, and so right off I'm going to talk about some of the AI work that we did. And we used what's called generative adversarial networks. If you've got a phone, I would like you to pull it out right now and type in, "This person does not exist." Okay? And this is something that many years ago NVIDIA supported. But once you do that and you hit enter, you will see, what do you see? A random face. Okay, thank you. Do it again. Reload it. It's a different face. These are all faces. They're not from a library. They've not been seen. They're created just for you. Okay? And if you're sitting next to somebody else, you'll see it's not the same face. Everyone's getting a unique face as they reload this. And it's being generated from an AI method called generative adversarial networks. And, I want to stand over there, but I don't. Excuse me. Of these 4 faces on the right, which is real and which is synthetic? Can you tell? And I don't want to spend any more time because they're all fake. They're all fake. They're all generated just the way you generated that face. And I would say, and this is an important point, they're not from real people. This is very subtle, but they are real images. They are real images of people, right? They're not images of real people. Very subtle. But I'm going to get back to that as well. So the way this is done is with a training set. People have scoured the internet, collected images of faces, and used that as a training set. And there's a methodology, GANs, generative adversarial networks, that's relatively simple to train what's real and what's not real. And it's just sort of a feedback loop, and it goes pretty quickly, and you can tell by how fast you hit reload on your phone how quick you can generate another face. Once the algorithm is properly trained, it works very quickly. And we saw this, and I was excited. I think it's super cool, first of all. And then I was super excited to think what we might be able to do with that, how we could use that. And what we started to do was to use a training. Let me go back. I just want to say one more thing, maybe a couple things. If you look at these faces, you'll notice all the eyes are in exactly the same position. So this is part of how this needs to work. There's a reference point. Even if someone's head has been turned, you'll notice that the eyes are in the same position. They're just back further off. So they're all centered. You'll notice there are children and adults. If you do a lot of this, like I've seen this a lot now, the people are I'll call them very handsome. They're all very handsome people. And the reason why is that the training set is scoured from your Facebook photos and Instagram photos and celebrities and people that are very handsome. And so the training set gives you what you're teaching. So we did the same thing with antibodies. We took a training set of all known antibody sequences from a public database, and we created a GAN that could generate antibody sequences. And I'm going to come back to this subtle point. Are those antibody sequences that we created that are trained by human sequence, are they human sequences or are they synthetic sequences? I would argue that they're human. They're human. They're trained by a human set. We all have the ability to make these antibodies with our B cells. Our B cells contain the information to make these antibodies. Whether they've been made or not, I don't know, because I only have 1 million or so antibody sequences in my training set. But if I had billions or trillions, I would guess that a lot of them that I'm generating here are, in fact, human antibody sequences. This is very cool. The next leap, and I'm not going to talk about this too much, but from a manufacturing perspective, we can bias, and usually you hear of bias in a bad way related to AI, right? Like they're biased, so that's a bad thing. But what we wanted to do is to bias intentionally towards antibodies that have properties like low viscosity, right? or long elimination half-lives. These are desirable features for a pharmaceutical to be able to control. And if we can control them and we can generate antibody sequences with a computer program, this cuts out a lot of the hassle, the time in finding therapeutics that are of interest to us. So we made this library. We did some panning. We created a library with yeast. A yeast panning experiment is what we did to identify antibodies that would bind to antigens of interest. And this was going on, I mean, obviously at the time of COVID, and there's a lot of interest. And so we took SARS-CoV-2 as an antigen, and our library, which was created by a computer program, and we found many, many hits of antibodies that could bind to SARS-CoV-2. I mean, to me at the time, it was mind-boggling. And how fast AI has moved, this is, today this is more trivial. But 4 years ago, this was a huge accomplishment that we had done. And I was totally psyched about this, and I feel like it will change life science, not just this discovery, but all the applications we have for AI in healthcare in particular. So exciting, and in other fields as well. And I know there's a lot of issues about bias and ethics and how do you regulate these things, and even these antibodies. The woman who did all this work, and is a good friend of mine now, in later years she said, I wonder how biased these antibodies are, because they likely came from North America, European, people who could go into hospitals, had their blood drawn. For some reason, they were interesting enough that somebody sequenced their antibodies. They're probably wealthy people, and I think she's probably right. I think that we're generating a set of antibodies from people who have a certain sort of genetic background. And we probably need to think long and hard about this before we put these things into people who maybe don't generate them as, I believe they're human, but I'm not sure if genetic profiles of different people might have reactions to them. I'm not certain. And these have not yet been in patients still, to my knowledge. So it's unique, interesting. Okay, I think we're doing good on time. That's kind of that was the end of the AI part of this. I'm going to talk a little bit more about the direction today for this company is around the manufacturing side. So what we've done in this industry historically, it's challenging because you need to have a plant before you know if the drug works exactly, because of the timing and how long it takes to build the plant. So you start your clinical trial and you get excited about this and you think, well, we need to build a plant. Well, this costs, a lot of money. And in fact, recently there's a story with Biogen, who had a drug in phase 3 clinical trials for Alzheimer's disease. And they looked at the size of the market, and the dose was massive for this. It would have been the highest dose of any biologic product ever made, and there would be more people on Earth that had used this than had ever needed one of these kind of therapeutics. So Biogen said, this market is massive. Let's build. And they built a plant in Switzerland for $3 billion. It cost them $3 billion. And they said, well, if the drug doesn't work out, we can contract manufacture. We can use it for our other products. But this just seemed unreasonable to me and my colleagues, and the work we had done together at Amgen told us that there's better ways to do this. And the technology we use is what I call dewatering. So removing water from every possible step in the process, because it's the water that increases all the size of the facility. And even you start with a cell culture in a vial. If you can concentrate those cells up by tenfold, you don't need to put as much into a reactor. You can shrink the size of the reactor. And we started feeding the cells with enriched media that's more concentrated, gets rid of the water. We started using disposable reactors for manufacturing because in reusable stainless steel reactors, you have to clean and steam, sterilize, and test the reactor every time you do a new batch of material. So we were doing it in a plastic bag, one time, throw away the bag, next bag. We were using very concentrated media. We were concentrating up all the steps in the process. And that's what the technology was about, was get the water out. And it's even a big deal in the plant because people have to move these things around, these tanks. And it's more flexible if you use a smaller tank. And you can have two people on the manufacturing floor wheel this thing around on wheel if it's 1,000 liters as opposed to 10,000 liters. So we did a lot of this work. We built a deployable facility. It's out in Redmond, and it cost about $100 million to build that facility. And it can put out not as much as that Biogen facility, but a third. We can put out in a year about a third of the output of that $3 billion facility. This is massive. You know, if you're in a startup or you're in a company and you're thinking about how much does it cost, how much could you save, could we pass that savings along to people that are trying to get access to these, you know, life-changing drugs? This is what it was all about. It's fantastic. This is the facility. We call these things, they're pods. They're really autonomous clean rooms. So you could build a facility that looks like a I don't know, a Costco building. And you can put the walls up fairly quickly, fairly inexpensively, and all of the activity happens inside the pod. And we call these J pods, they're just pods. Which seemed clever at the time when we named it because everybody had iPods in their pocket. And we were like, these are J pods. I think there's a pod of whales in the Puget Sound called the J pod that comes back every year. And we saw that, and we were trying to use that in our branding, you know, it was fun. So that facility got built. It's on the ground. There's another facility that's being built and right now in Toulouse, France. So I'm going to shift and talk about building blocks for startups. Why would anyone do this? Why would you start up a life science company in particular? And by show of hands, how many of you are life science background? A few. Okay. I mean, there's a good number. You know, for us, having been in the industry for many years, it was sort of a chance to give back. You know, we benefited being in that industry a lot. At a time in history when people had enough money and we're collecting data to show that we're making a difference in people's lives. You know, it's not just palliative anymore. We're making a difference in the length of people's lives and how they feel. I have to tell you about one experience I had with a woman. We made a drug called Enbrel, which is for rheumatoid arthritis. And she came in to visit us, and I was in the lab, and she put her hand out, and she said, I want to thank you. I want to shake your hand. And I said, okay. And she said, I want to shake your hand. I said, okay. And I shook her hand, and she said, I couldn't shake someone's hand before I took Enbrel. It was like, this is why you do it. I mean, there's money. These are startups, and it's money involved, but here's somebody you're changing their life. And she was able to hold her daughter and use her hands again, and she loved to bake, and I talked to her some. It's really powerful experience to be able to touch somebody create a product, whatever it is, and make a difference in someone's life. I know a lot of it's about the money, but I think in the end, there's more than that. It really is. And those are the products that are important, those that go beyond, they kind of transcend financial results. And I don't mean to poo-poo it, because the way our system works, you need the money. You need the investment, you need the return on your investment, that's important. But my experience was, in my life, the highlights are shaking this woman's hand, amazing. So I mentioned it was a bit of a unicorn event to me, the way this company started. So we knew there's this need, low-cost biologics. We had a lot of experienced and passionate people. When Amgen left, Amgen didn't want to be evil, but just financially, right? I mean, they did all their calculations, and it made more sense to consolidate in other parts of the US. And they said, thank you, but we're leaving Seattle. And they didn't want to be cruel about it. So they were actually quite kind to us, and they let us stay. It's funny, down on the waterfront, there's a building, and it houses about 1,000 people. Well, there were 3 of us in there when they all left, and they were allowing us to continue to use the equipment there because there had been this big Ebola. This was the time of Ebola. And they said, yes, you can stay in our building. The Gates Foundation got involved, and we were making Ebola antibodies. Just a small group of us. And then we were trying to hire some people, and the Gates Foundation paid for us to hire back some people. So we knew what we were doing. We were in the building. This is a one-off sort of thing. It's not a typical thing. But we had all these experienced people who were technologists and wanted to advance the technology. And in Seattle, there's all this computational expertise. We were right down there in Amazon. We were in South Lake Union when we started this thing up. The people that came did some of this work I showed you for generative adversarial networks, and they didn't really know much about life science, but they knew a lot about computational work and GANs, and it was like, wow, we're right here. The Gates Foundation is here in Seattle. There's global health at the University of Washington, a big deal. This just all made sense to us. Of course, the resources are here, venture capital. The intellectual resources are here in Seattle, biotech. I mentioned these things. The timing of the Ebola outbreak was sort of serendipity, entirely serendipity, that it happened. And there we were. There's some challenges here. We thought that we would start this as a non-profit organization. That was our intention. And when the Gates Foundation got involved, they said, we love who you are, we love what you're doing, but we do not want to invest in a non-profit entity. We'll invest if you are for profit. And that kind of struck me. I was a little confused by that, but as time went by, it made more and more sense. Their experience told them that these for-profit companies had skin in the game. They were trying to build something, and the nonprofits, they were having more trouble keeping them going, and they would come back a year later and say, we need another $5 million or else this thing is going to go under. And it was more prolonged. They wanted us to be for-profit, and I think it made total sense after I was in the company for a number of years. For us, we needed to invest in technology, and really we were a technology company. Our product was technology. We were selling the technology to other companies that wanted to license that technology from us and use it in their own companies. And Merck was one of our early investors, a big investor, and they wanted the technology because they were trying to pivot from so-called small molecules to protein molecules. They wanted to make that pivot, and it wasn't easy for them because they have a long history of making small molecules. So they were investing in our technology. They knew who we were. They knew what we did at Amgen. This made a lot of sense. Lab space is scarce and expensive in Seattle. If you didn't already know that and you go out there to look for it, it's hard to find. I think it's a big advantage if you can spend some time in Fluke Hall and with CoMotion, it's a huge advantage to you to get your company off the ground because it costs a lot to do this. But the rewards are there. The mission is big, and the financial rewards for us was to create. The idea is to create more global economies. And can we do this in Africa? Probably not exactly. Could we do it in Johannesburg? Could we build one of these facilities in? Maybe. Is there enough? Could we get that off the ground? Could we do that in China? And we did it in China. As part of our VC wanted us to invest in our technologies into a Chinese entity who was doing the similar kind of work. So we did that. We got that off the ground, and they took a lot of our small scale, large output technology into a company there. The business model, as I just mentioned, it was really a technology company, especially in the early years. We were looking for grants, non-dilutive ways of getting off the ground. The Bill and Melinda Gates Foundation, we ended up getting very well funded by the Department of Defense. We were closely aligned with DARPA in a lot of the work that they were doing. It ended up paying off in a big way when this thing called COVID hit. And I was spending a lot of time with the Department of Defense, flying back and forth, and it wasn't really going anywhere until COVID hit, and then they came and they paid us, at this point, over $100 million. And for that small company, it was a massive amount of money to bring in. And we had our facility built. We could make COVID antibodies for the Department of Defense, for the military. They wanted their own supply of COVID antibodies. You remember, there was a time where we didn't know how long this was going to go on. So that was great. We also did contract development and manufacturing, so we could make antibodies for other companies who had an interesting product idea but didn't have their own manufacturing facility. And we got a pretty good margin. At the time we were getting 40% margins. We'd charge $10 million to make enough to run a clinical trial, and it cost us $6 million to do that. We were out licensing the technology to Merck. They were paying us for the technology and building their own small facilities, so we were making money that way. And the idea was to eventually, and perhaps they're there today, I've been out of it for a little over 2 years, but new molecule discovery, and eventually that could lead to royalties. So this is the model. We got significant equipment. This sounds trivial, but we got about $10 million worth of equipment value from Amgen. They didn't want to put it all in trucks and drive it back. And they said, just keep it. It's a donation. We like what you're doing for Ebola. We want to support you guys. This is a one-off thing. We had Series A of $15 million from Merck, Eli Lilly, and that's the China arm, Lilly Asia Ventures, and Arch Venture, a big VC company. And then we got an A2 round from the Gates Foundation, another $14 million, and that helped us to build a clinical manufacturing facility downtown. And in return for that, the Gates Foundation had access to protein manufacturing for their other partner organizations at cost. Now, we didn't make any profit from those that we did for the Gates Foundation partners, but we did it at cost for them. Lab space in Seattle can be expensive. We were at IOG over in Fremont, which you can't even tell what it is when you drive up to the front of it. It's like, what is that? But we were in the basement of that building, which is right here. And you might see in the back corner there is a garage door. So we were truly in a garage door sort of environment. And for us, we're a life scientists trying to culture cells, worried about contamination. And we had this garage door going up, and we would wheel equipment down in there. And it was probably the most fun period of my entire life, my entire working career. The most fun I had was in that building. It was kind of like, remember MASH and these guys, they were in a different part of the world, and they were getting their business done. And it might not have conformed to everybody's expectations of how things should be done, but their heart was in it, and they were every day trying to help people, and that was the mentality there. We were like, well, we have contaminations. Maybe we can't open this garage door anymore. What are we going to do? You know, it was just every day trying to figure out how to solve these problems, and it was great fun. And eventually it got acquired by a company called Evotech. I would say we sold it. I didn't sell it. The investors sold it. I didn't have the ability to say, I'm just telling you this because these are the realities of starting a company. You might not have the ability to say, well, I don't want to sell it right now. You know, if the other investors say, I found somebody who wants to buy it and I'm ready to sell. I mean, it's just so the attachment I had, and you will have if you start up a company, is very strong. I birthed this company, okay? And I needed some investors to help me to birth this company. And then I needed some more money to build a manufacturing facility. These things happened. Well, my stake in it became less than their stake in it, and they made decisions. And I'm not actually against the decisions because they came and capitalized this whole thing. They spent $100 million putting this facility and another facility on the ground. The company is now 500 people, right, in 10 years. It needed this growth. We got to a point where we made $1 million one year, more than we spent. It's pretty great, but if you want to build a manufacturing facility that costs $100 million, you know, you do the math, it's 100 years. You need capitalization to get that done. And that involves other investors and things change. I actually like that company a lot, Evotech. I like what they're doing. I like the people there. I stayed with it for a couple of years, and then I needed to take a big, long, fat nap, honestly. And then I saw posted, I think it was something you posted on LinkedIn, and I was like, oh, you know, an instructor in the department I was in, it's kind of like full circle for me, and it's a way I can bring back what I learned in industry for other students and maybe help to propagate all of this. Lessons learned, the mission, the culture. You can state the mission, but the culture is built internally. It has to come from the people. And I had one experience where we watched this movie called Remember the Titans, which took place in the South. And, you know, there was a football team, there was black players and white players, and there was all this problem, and the coaches and the school district said, you're going to play together, and the coaches kind of argued and all this stuff. And eventually the player said, I don't care. I just want to play football. That's what I want to do. And that's the culture. And you cannot impose that culture as the coach of the team or the superintendent of the school district, that this is how it's going to be and this is who's going to play. It comes from the people in the company, what kind of culture your company is going to have. So the way you hire, I mean, you can have some control, but hopefully it's the people and the way you emulate the behaviors you'd like to see. So lessons learned, great mission, great people, great ideas, a solid business plan. Especially if you can make a little money from your business plan. In this industry, a lot of it has to do with, I have an idea to cure cancer, and you get some money. Well, it's all or nothing. You know, this is going to take us 5 years, 8 years, 10 years, and we're going to find out it didn't work. Done. The company is done, and it happens all the time. I think it's really important to get some sort of revenue as you're building, and it allows you to do a lot more. Like a service, even to be a consultant, you know, even to put your skills out of your team as, hey, we can provide consulting hours. That's great. So there's a team, great team at the time, and I'm just about where I want to be, because I want to talk a little bit, I want to shift a little, and I have a couple more slides that I want to share. And these are my experiences as a manager working in industry for all these years. And I think that for me, and there's probably a lot of ways that are in Harvard Business Review papers of these kind of attributes and what are the most important attributes, but this is how it works for me over time, that there's innate attributes that people have. They do. And you can learn other attributes, but I think you have a strong built-in bias, and that's okay. And I'm not sure it's a good idea to try to change that. I think you are who you are, and you can be great at who you are, and you can improve at other things. So professional attributes are innate, but they can also be learned and improved. I believe that too. But I think that when you're not in the work environment, and let's say you're in your car driving home, you're still working on those problems. Or you're sleeping at night, and we're solving the problems in our life. It's just happening in there. And you can't control it. You can't control the way you're solving those problems. So I would pose to you that you would solve it in different ways. Different people. Some are more technical, and they're thinking about technical solutions, and they're thinking about a paper that they read and something they want to try and apply that. It's just going on in the background. And I think it's really important to pay attention to these moments in your life about who you are and how you think and how you solve problems. So I think there's these three, what I'll call these pillars. One is your capabilities, technical, managerial capabilities. And when I look at someone's resume, I can see it without even interviewing them. I mean, the University of Washington conferred upon this individual a master's degree in this particular area. That means something to me. I mean, it stands for a certain level of performance and expectation that the university had that I can bank on. Or they worked at such and so company and they did this work. It tells me something about their capability. I can see it on a resume. Output, how hard does somebody work? And you guys all know that person that worked with you in a group and they didn't put much effort into it. They were very technically savvy, but they didn't work hard at it. And they're probably the most frustrating because for the rest of us, I'm willing to work really hard and I might not be technically superior. And it kind of hurts me. Like, I want to work, let's do it, let's make it happen, but I might not have all the technical skills. And it's a little harder for me to compensate, and I feel like, wow, if you've got all those skills and you work hard, imagine what a person could do. The last piece is teamwork. And I think these first two I can see in a resume. So if I talk to somebody on the phone I want to hire, I'll see all this and I'll say, why don't you come on in? And it's teamwork is what I want to find out about. That's harder. I can't see that in a resume. And the person, I'm going to talk about labs. The person you guys have probably worked with or lived with, they just leave a big pile of stuff in the sink. And they walk away because they have something more important to do. I have these technical ideas and I'm trying to write a paper and this is really important. And other people who are maybe less important, I'm going to expect to clean up after me. And they're very difficult to have on a team with you. These are very difficult people. I believe that a normal human is good at two of these three things. And I think I'm good at two of these three. I think I'm good at output. I don't mind working hard. And I'm good at teamwork. I don't mind doing this for the university, right? I'm in. I wish I was better. I wish I was technically, better. But I think I'm a normal human, and I think a lot of humans, they're two of the three. If you are three of those three, these people stand out. And when you meet somebody like that, they kind of strike you. It's like, wow. You know, I like them. They're easy to get along with. They work hard, and they're really smart. These are kind of, you know, these are rare people, but really great to have on your, you know, in your organization. And if you're only good at one of these three things, you're a liability. You are dangerous. I do not want to hire that person. I mean, if you think about it, like they're not very good technically. They don't have very good output, but they can work on a team. I mean, how do I move forward with that? How do I use that? So I would review my employees every year and say, excuse me, you know, where are you and where do you want to be? I'm going to get into this in the next slide. You know, are you technically savvy? Where's your weakness? And they would tell me, and that was a good discussion because I would say, yeah, I agree, or I don't, you know, I don't. And that was a good discussion to say, where's your weakness, where's your strength? And they would tell me that. And then I would say, well, if that's your weakness, let's find a way to improve that because it can be improved. It's not innate for you, maybe, you know, being on a team, but I can assign a project to that individual to say, I'm going to give you a mentor. I want you to serve on this team. I want you to talk to the mentor and then come back to me once a month and let's talk a little bit about your experience in working on a team because that's what they could improve. And I like this approach because it's not judgmental. I'm not saying your output's not very good, but I'm asking you where could you improve? And let me get to the next slide and this is my last slide. I plotted these out over the years and thought about this and how this makes sense to me. And I'm going to plot on one axis technical skills, and the other axis I'm going to call this team skills. And I find that people get their jobs done maybe in different ways. And that's okay. Again, there's no judgment. Some people are technically very strong. I can use this. Can you see that? No, that's okay. And you can see, you know, where I wrote technologist along the left side. If you're a lab scientist or you evolve in your career, you become a manager, and maybe you become a vice president, and then maybe you're on the C-suite of some company. You can get your jobs done in different ways. Technologist on the left, team kind of skills on the right. So I'm going to give you some examples. People, when they first graduate in technical areas, I mean, that's the currency that they have is technology. That's how they get their jobs done, is they apply the technology that they've learned to the problems that approach them. They're not thinking so much about the team part of it until they become a manager. And it's like, okay, now I need to work with this person and show them how to do what I want them to do in a way that doesn't make them angry and want to quit. And, you know, this is like the team thing. I'm faced with the team thing. And then maybe someday I become a vice president and I've got multiple teams reporting to teams that are reporting to me, and I need a bigger vision about how these teams fit together and what's my hiring plan. And over the course of your career, this thing starts to bend. For scientists, it starts out going kind of up and down, but over time it bends to the right. Okay? And this happens for other people who come at this from a different direction. If you have an operational mindset, and I'm going to give you an example of the difference here. The technical person develops, let's say, an assay for activity of a drug, and they use a cell, and the cell turns the liquid in some color. You know, it's like very technical. And they apply their skills. Great, they've done that. And then they throw it into an operation. And the operation person says, well, hang on, this is a 12-hour assay, and I have an 8-hour turnaround. Employees only work for 8 hours at a time. So I need some kind of a process in place that when I start the assay, the person on the next shift knows that was started and they take it off. And in fact, depending on the time of day that it got started, if it got started at the end of one shift, it jumps over into 2 shifts later. And I would tell you that this is not easy. And it requires somebody with a mindset of, how do I communicate this? How do I create a team that communicate with each other? And they rely on the ability of the person who set this. Do you see what I'm saying? Like, both of these skills are important. You don't tell everybody, oh, you're not technical enough, therefore we're putting you in quality control. I mean, you could argue the other way around. I mean, to the technical person, say, you're too technical and you don't have the ability to interface with people. But I think in the organizations that you build, you need all these people. You need all of them. And you need to value them for who they are. And where this X is where I ask the question of a person that worked with me. I'd say, where are you? And they'd say, I'm here. And I might agree or disagree, but I'll tell you 90% of the time, I think we were in the same zone. And they'd say, I think I should be promoted soon, right? I think I should. And I'd say, well, what would help you to get there? And they would tell me, I should have more of this team skills. Is there an opportunity for me to do more? If that's really where you want to go, I'm here to help you to get there. I'm not here to judge you for who you are innately, but to try to, create the best group of people I can possibly create. I think these in the middle, I'm going to call these org leaders. And I think they're people that have enough technical abilities and enough interpersonal skills that they can relay those technical abilities to things that have to happen on the ground that are not experiments. And I think they can get the trust of both of these organizations. So as you get to the top of this thing, finally, C-suite. So where on that would be a CEO? Where in that? Yeah, I'm in my last moments. So, anybody have a shot? Where would you put an X for a CEO out there? Where's that? Org leaders? Yeah, could be. I mean, I would put them probably in the middle, and then I'll ask about another one. How about like a CSO or CTO, Chief Technology Officer? I mean, I would hope they would have more technology savvy, but a lot more soft skills than maybe some of the technologists that work with them. And then Chief Operating Officer. I mean, it's about the buildings, it's about HR, it's about the operation. I'm doing them in order because they're probably a little more in the bottom right. Yeah? So when a company gets started, who starts it, right? That scientist. And you get years into it, and they're not necessarily the right people anymore. And you need to think about how do we shift? And it happens, a lot with startup companies and VCs look for these kind of people. Like, are they flexible enough that when we bring this company to a successful point, can the former CEO step aside and bring in somebody who has more of this kind of operational sense for the whole thing? So anyway, I hope that was interesting. I'm finished. I didn't give much time for questions. I'd be happy to take a few and even hang out. I'd be fine with that. So please, yeah.
Thank you for the talk. I was really interested when you were talking early on, and you were saying the silos between the drug discovery and then the development of the drug and then the manufacturing. And I see that trend a lot. When you guys were raising money and developing through those sections, were you able to maintain the same staff that stayed on from that beginning discovery stage through to the manufacturing? Because that would kind of help that siloing bring the people through.
Yeah, I totally understand where you're coming from. And I think that's a problem, for sure. My thoughts are the organizational size. So as we grew, And I left the company, I was 150 maybe. I think group size is important. And I think that groups of about 50 are manageable. And the number of layers you have in a group of 50 is probably 2 layers. So you could have 7 people. You could have somebody who manages a group of 50, and they can manage 7. That would be a lot. And each of those people could manage 7. So that's 50 people with only 2 levels of, in between the lowest and the highest. And that's good in an organization that you don't have a lot of stratifications, because then you lose the communication. And so there's this balance between size of the organization and ability to communicate. And we thought a lot about how can we maintain this in the future and keep groups about 50, no more than 50, and have them do the work from A through Z, that team. But once they get to the end, and then they get on the conveyor belt again, and another team of 50 would come across. So that was a kind of a magic number for us that we kept in mind. But it's a great question. And I think these things get too big, and this is major biopharmas. Pfizer just bought Seagen, and they let go of a whole scat of people.
That's what I was had in mind, actually.
Yeah, and the way they justify it is they're more efficient. They say, well, we don't need multiple people doing regulatory affairs because Pfizer can do everything. And you lose a lot of people, and it becomes more segmented, geographically and people-wise. You have bigger and bigger organizations of bigger and bigger sets of people. It's hard. So I've worked in small, medium, and large. I think I like the medium. Small is really hard work. What you guys are about to do with startups is really hard work. All day, all night, all weekend. Yes, please.
Hello. I was very curious about the artificial intelligence aspect of what you were doing at the beginning. I'm doing a hardware startup. My question is, do you have advice or resources to apply AI to, early startup business? What you talked about didn't seem to apply, but maybe you have insights that you could
how can you apply AI to your hardware business?
Correct. Yeah. Or it could be to the business. It could be to the technology I'm making.
I'm going to teach AI for bioengineers in the spring, I mentioned. And my first slide is fire, the wheel, and AI. And because I believe it. I don't think this is just advent of computers and the internet. I think this is transformational. And I'm hearing people say, yeah, but it can be biased or, these things. I just think we need to get on board and fix those things. It's happening so fast. It's hard to even teach a class on this subject because it's happening so fast. I am listening as much as I can to podcasts. I'm reading as much as I can, books. I'm going to presentations. There's a town hall in Seattle, and they're doing a lot of things lately about AI, which are really, really cool. The people that are out there, I don't have any specific advice for you except to say the departments, and I went up to computer science because I wanted to see myself what was going, and there's a buzz of energy up there. If any of you guys are part of that building, it has the physics on the top floor. I got off the elevator and I felt it, and for me it was at the university a big difference. There was a buzz. And people were coming in, and they were investors. They had suits and their briefcases and ties, and they're investors. And a lot of people along this wall, like this big, and they told me any investigator at the university can come and get 160 hours of advice on how to apply AI to their projects. And he said that was a result of a grant that they received from the government, and I thought, wow. And they were all busy as could be. It's just, that's the kind of department that has it. My department in bioengineering will have it. I'm 100% convinced they'll have this application of AI as a major offering of what they do. It's just going to take, the time. And some people I'm hearing already say, yeah, there's a lot of hallucinations. I'm not very impressed with ChatGPT. That's fine, but it's coming like a tidal wave at us. It'll be there, and it'll be there for you too. I wish I had a better answer than that, but I'm just trying to put as much as I can into learning as much as I can about AI right now.
Okay, thank you very much.
Yeah, thank you.
All right, well, thank you all for joining us today. And from everyone at CoMotion Labs, a big thank you to Dean Pettit for sharing his story with us. So thank you, Dean.
Yeah,
Then remember, next Friday we have Richard Giersch from Life Sciences Washington, the executive director, and he'll be presenting on demystifying federal funding opportunities. So please sign up online, and we'll see you next week. Thank you, everyone.